stress increment. So we'll be looking at how to determine the vertical stress increment on a foundation at any point. So this particular problem says a 4.5 meter square foundation has a contact pressure of 200 kilonewton per meter square. Determine the vertical stress increment due to the foundation load to a depth of 10 meters below its center. Take the influence factor at 2.5 meters to be 0.163, at 5.0 meters to be 0.074, at 7.5 meters to be 0.04, and at 10.0 meters to be 0.025. All right. Now, normally for us to solve this kind of problem, the first thing we determine is, the question says at the center. The first thing we do, because of the graph that we'll be using, okay, the Fathom graph, the first thing we do is to ensure that the points we are considering is at an endpoint of a shape, be it a rectangle or a square. So if we divide this square foundation this way, and then we divide it this way, you can see that we have the point at the end of a shape. You can call it either at the end of this square, at the end of this square, at the end of this square, or at the end of the square. That's the first thing we determine. Then the next thing we determine is our M and our N. We know that our M is equal to B over Z, and our N is equal to L over Z. Why do we get the value for our M and our N? Is to determine our influence factor. But for this given problem, we have been given our influence factor. Hence, we don't need to determine our M and our N value. So we are asked to get the vertical stress increment up to a depth of 10 meters. Now, vertical stress increment, sigma Z, is given as the pressure times the influence factor. All right? This is basically what it is. But before we get this expression, we have to determine, before we got the points being considered to be at the endpoint of a shape, how many shapes we are gotten. So we can see that for this case, we have 4 squares. Hence, our vertical stress increment will be equal to P times 4 times our what? Influence factor. So from this point, we are given our influence factor and we have our respective depths. So to determine our effective vertical stress at different depths, it is simply what? This is in kilonewton per meter square. It is simply what? The load times 4 times what? The influence factor. All right? So let's get 4 times our influence factor first. So let's call this column 4 times influence factor. So 4 times 0.163 will give us what? 0.652. 4 times 0.074, 0.2929. 4 times 0.04 will give us what? 0.16, right? And then 4 times 0.025 will give us what? 0.1. And then on this last column, we can have this expression for our vertical stress increment, which is in kilonewton per meter square. And this is equal to what? Our P times 4 influence factor. So we have this. So it's going to be 200 times 0.652, and that will give us what? 130.4 kilonewton per meter square. 200 times 0.296 will give us what? So 200, this will give us 59.2, and it's a kilonewton per meter square. 200 times 0.16 will give us 32 kilonewton per meter square. And 200 times 0.1 will give us what? 20 kilonewton per meter square. And this is how to determine our effective vertical stress increment when we have been given the influence factor at the center point of a what? A squared foundation.